What will it take to make it to the top? What will it take? What will it take? What will it take to make it to the top?
Hello, hello? Okay. I'm going to go ahead and get started because we have a lot to get through today. I wanted to welcome everybody to IoMT Data to FHIR. This is a Let's Build session. Just out of curiosity, how many people were here for Dustin's session, just the session before this, regarding the IoMT FHIR connector? Okay, great. So you have some context as far as what we're building here. So I do want to start off with saying there are actually 3 prerequisites here. Number 1, you should create an Azure account. If you haven't done this, you might have enough time to get it done during this introduction. The other thing you need is a Mac. If you don't have a Mac, Microsoft thanks you. But you're not going to be able to do the second part of this Let's Build because we're going to be deploying an iOS application in the iOS simulator. And you're also going to need Xcode 11, which you're not going to have enough time to download it because it's 8 gigabytes and it's going to take about an hour to install. So if you still want to participate, though, the slides are going to be available afterwards, or come see me at the Microsoft desk, and we can walk through it together after that. So a little bit about me. I'm a software engineer for the Microsoft Health Cloud and Data team. And the things that we're working on, I work on the same team as Dustin, so IoMT FHIR connector, but just in general, IoMT solutions. So we're focused on bringing IoMT data to the cloud and specifically getting IoMT data in FHIR so that it's interoperable. I won't spend too much time on this slide because Dustin kind of went over it before, but what is IoMT? It's the Internet of Medical Things. So it's a subset of IoT devices. They collect patient data, things you can wear, like wearables, Bluetooth scales, Bluetooth thermometers, things like that. Sometimes there's sensors in hospital rooms where you walk by can get your heart rate or blood pressure. So like I said, I'm not going to spend much time on this slide. Just kind of an outline of what we're going to be doing today. I'm going to give you an overview of what we're actually building. So there's 2 components, an iOS application and then the IoMT FHIR connector, which we're going to deploy in the cloud along with a FHIR server. Then we're going to deploy the cloud services using a PowerShell script. I want to get this done early because it takes about 10 minutes, and I want to make sure you have enough time for the script to run, and then it's going to output a config file that you're going to use to point the application at those services. And then during that time, I'm going to go over the IoMT FHIR connector. Some of it's going to be some recap of what Dustin did in the previous session. And then we're going to talk about HealthKit on FHIR, which is HealthKit on FHIR is a Swift library that we developed, and it exports data automatically from HealthKit and then converts it into FHIR format. So it stores HealthKit data as FHIR resources. And then for those of you who have Macs, we're going to deploy the sample application using the iOS simulator and then test the pipeline out by putting data in HealthKit. And then we should see that data do this round trip from your iOS simulator into the FHIR server. Okay, so the overview. So in a real life scenario, you would have this IoMT device, so a patient would be wearing a wearable or using a scale or a thermometer, and this data is actually flowing into HealthKit. So the HealthKit on FHIR Swift framework, when it sees this new data come in, it's going to do a query on HealthKit, take the data, and then pipe it through the IoMT FHIR connector for Azure, which then transforms it into FHIR resources and then saves it into the FHIR server. Now, there's another path for the data, which is we can use the Swift Smart framework, which is a framework that was developed by Pascal and some other folks. Is Pascal here? He works at Apple. I'm not going to really go into this because I really want to focus on the IoMT FHIR connector for Azure. It has a lot of functionality as far as handling high-frequency data, so things like the Apple Watch can sample it every 5 seconds. So if you are in exercise mode, your heart rate will be measured every 5 seconds and then put into the cloud. And creating a resource, 720 observations for heart rate every hour is going to blow up your FHIR server. So that's where the connector comes in. The other thing I'm not going to talk about is the other dependencies that we have. The HealthKit on FHIR uses a couple other frameworks, so I'm not going to go into that just because of the time we have. Okay, so just to recap here, we're going to be doing two things here. We're going to deploy cloud services using a PowerShell script, and then we're going to deploy a sample application using Xcode. Okay, so let's build. So hopefully you've created your Azure account. You want to navigate to portal.azure.com. I'm going to give you just a couple seconds here to do that. And Brendan over here is going to help me do this, so he can let me know when he gets there. You're there? Oh, the other thing I want to mention too is Dustin can help out if you guys get stuck. So if you get stuck, raise your hand. Okay. So hopefully you're at portal.azure.com. It should look like the screen on the right here. And then you want to navigate to your Azure Active Directory. So there is an icon here. It looks like a pyramid. Just click on that, and you're going to go to Azure Active Directory. Just out of curiosity, how many people are actually building? Because I'm going to be looking at you. Okay, perfect. All right, next you want to open the Cloud Shell. So your Azure Active Directory, you should be on this page. You should see default directory. It's this black header here. So in the upper blue header of this page, you're going to see this icon right here. Just click on that, and that's going to launch the Cloud Shell. So if you haven't used the Azure Cloud Shell before, you're going to get prompted to do two things. Number one, select an environment, and then number two, create a storage account. So you just want to click on PowerShell for the environment, and then create storage account. How we doing, Brendan? Have you created a storage account? And you said you're building too, right?
Yes, but I did it before, so.
Oh, you've already done this before?
No, just
Okay, perfect. Okay, let's move on. Okay, so like I said, it's going to take about a minute. This is what your screen should look like. So you should have the Cloud Shell open and a command prompt ready to accept commands. So the first thing we're going to do is log into your Azure subscription, and this is done by typing in login-az account. Now, I know it's kind of weird, you've already logged into your Azure account, but the Cloud Shell doesn't have any context to the user that's logged in, so you have to do the login one more time. And this will allow the PowerShell script to actually create Azure resources in your account. When you type this in, you're going to see this message. It's going to prompt you to go to this Microsoft.com/device login and then type the code in. The easiest way to get this done is you just select the code, you copy it, and then you should be able to click on this link, and it'll open up a separate browser tab. You can log in, and then you can come back to this. Okay. So the next step is we're going to connect Azure Active Directory. So this command is connect.azure-azure-ad, and you're going to pass in a parameter called tenant domain. So it's dash tenant domain, and then you get your tenant domain by copying just above where it says default directory. You're going to see something, probably your username or whatever you logged in with, and then on Microsoft.com. So I'll go here for this side of the room. You're going to copy that, and you're going to pass that in as the tenant domain parameter. And similar to the previous step, you're going to get prompted to log in again. I know this is annoying. It's the third time you've logged in, but this is actually necessary so that the PowerShell script can go into your Azure Active Directory and set up your identity provider. And this will allow the application so you can log in. Okay, so now we're on the step where we can actually clone the repository within your Azure Cloud Shell. So the repository is located at Microsoft, or GitHub Microsoft/HealthKit on FHIR. So this is the actual HealthKit on FHIR project. There's a sample app in there, and there's also a deployment script that allows you to set up a cloud environment for the sample app. So I'll give you a chance to go ahead and clone that. Okay. So now you're going to navigate to the scripts directory. It should have cloned to your home directory, so you can use the tilde symbol here. So tilde/HealthKit on HealthKit-on FHIR, and then sample/cloud/scripts. This is case sensitive, by the way, so make sure that you get the casing right. All right, and now we're actually going to deploy the cloud services. So this is just one script that you run. The way you run it is /create-IoMT FHIR cloud environment.ps1. So you're going to go ahead and type that in, hit enter, and then it's going to ask you for 2 parameters. So this is kind of a tricky part here, but the 2 parameters are going to be environment name and then an admin password. The environment name has to be unique because it creates a subdomain for your services. So don't use FHIR DevDays, use a pet name, use something. The other requirements are that it has to be lowercase, letters or numbers. And then the admin password, it's actually going to print this password out in plain text, so don't use the password for your bank account or your Twitter unless you want it stolen. Okay. So this script is going to take about 10 minutes to complete, and it's going to output 2 things. So number one, it's going to generate a config.json file. Later on, we're going to use this to set up the iOS application. We're just going to drag it right onto the simulator screen. It's going to point the simulator to this cloud environment that you set up. And then, like I said before, it's going to print out a username and the password that you used. You can use my password, that's fine, FHIRPass1. And that you're going to use to log into the sample app. So I'm going to leave this screen up just in case somebody's lagging behind. I know you're building. These are all the commands that we did. And this is the only thing you need to do to set up the cloud environment for the sample app. Okay, so what is this PowerShell script doing? So number one, it's doing a bunch of things, but I'm going to talk about two things specifically. So number one is deploying the Azure API for FHIR, which is Microsoft's fully managed FHIR server. And then the other thing it's doing is it's deploying the IoMT FHIR connector for Azure. So this is the pipeline that Dustin talked about in his previous, the previous session. It's an IoMT data pipeline that that sets up an endpoint where you send IoMT data to it. It groups data appropriately, and then it stores it into FHIR resources. Here's the repository you can go to. You should star this repository if you're interested in doing IoMT work. And I wanted to talk a little bit about why we developed this. So we have been working with device manufacturers and researchers actually for about 3 years now. And it's not trivial to get this IoMT data into FHIR. And we had several different iterations of services, and what we landed on was the IoMT FHIR connector. Some of the important lessons that we learned is, Dustin went over it a little bit, was devices sometimes send data at high frequency. And it's not necessarily streams, they might just send data at frequent intervals. The other thing is, it sends these payloads with mixed measurements. So you might have a heart rate monitor that also sends up blood oxygen or perfusion index all in one payload. So you need a way to separate out those measurements and then create FHIR resources that represent those measurements. So what the connector does is actually provides an endpoint that you can process this high frequency data. And then the other thing it does is it allows you to process payloads that have that mixed data type. So data types that I just talked about, where you have a single device that sends up a single payload, and now we're going to split these things up. So the first thing it does is it normalizes the data into, and we're talking about non-FHIR data here, so IoMT data that sends it up to the cloud. It normalizes it into a common format so that the IoMT connector can do its magic. It groups it by device, time, and date, or device type and time, and then transforms it into FHIR observations. Finally, it persists the data into a FHIR server. So there are a couple things that I want to point out. Number one, the IoMT FHIR connector can point to any FHIR server, so you don't have to use the Microsoft offering. You could use another one. We recommend using the Microsoft offering, though. There's a minimum set of requirements. It has to be R4. It has to have CRUD for patient device and observation. And you have to have an OAuth 2 identity provider set up. And those are the only requirements. The other thing I want to point out, too, is though we're deploying an iOS sample app and using HealthKit, the IoMT FHIR connector does not require that you use HealthKit. It's device agnostic. So the whole point of it is you can send up data from different devices, different payloads, and then you can actually create templates that will map that data into FHIR. And now I'm going to talk a little bit about the HealthKit on FHIR Swift library. So what this library does is it automates the export of HealthKit data. So it sets up what they call in HealthKit observer queries and anchor queries. And anytime you get new data into HealthKit, it sees that new data has come in, it does a query, it fetches all the new data, and then it sends it up to the FHIR server through the IoMT FHIR connector. It also can export historical data. So if a user opts in to let you see their heart rate or blood pressure, when that happens, you could actually go back a month, a year, whatever, and collect all that data and send it up through the connector. And it simplifies the process of obtaining permission for that data. So you essentially declare what types of data you care about, what types you want to listen to, and then you can just call a single method, which is request authorization, and it will show the operating system UI to allow the user to opt in. So it really greatly reduces the amount of code that's required to get this to work. So why are we doing this? Why is Microsoft building iOS frameworks, and why are we building this IoMT connector? It's really to simplify getting this IoMT data for physicians and researchers. So like I said, we've been working with device manufacturers and researchers for the last 3 years. We think there's a need here. We think that it's heavy lifting to get all this data into FHIR, and so we've done the work. We want the community to benefit from it. We want you guys to use these tools, to experiment, to give us feedback, to contribute to the open source. And the other reason, of course, is to evangelize FHIR. If you have a choice between, hey, I'm going to go ahead and build this whole pipeline myself and then come up with my own scheme and store data, or, oh, I'm just going to spend 40 minutes and spin up this entire solution, we're hoping that you go this route, and then you'll just use FHIR. Okay, so now we're going to move away from the Cloud Shell. Just keep that window open, don't close it, and we're going to clone this repository, the HealthKit on FHIR repository, to your Mac. And this is so we have access to the source code so we can deploy the sample application. And then once you have it cloned, you're going to navigate to the sample directory. And there's a Xcode project in there called HealthKit on FHIR sample. And you're going to open that in Xcode. So it's going to take probably a couple minutes for the Swift package manager in Xcode 11 to resolve the dependencies. And if you guys haven't been using the new Xcode 11 and Swift package manager, it's pretty cool. So essentially, you can just point to any Git repository that has a package.swift file, and it's going to automatically just pull those dependencies in, check out the appropriate version. It makes it really easy to manage dependencies. I don't know how many iOS developers you have in the crowd, but using CocoaPods and Carthage is kind of a pain. Okay. So now we're going to run the application, the iOS simulator. It's important that you target an iPhone simulator because iPad simulators do not have HealthKit and they don't have the iOS Health app or the Apple Health app. And so you target the simulator and then just hit the play button. Okay, so once the simulator actually launches and deploys the application, it's going to ask you to drag the config.json file into the simulator. So hopefully by now, your script is completed, your cloud services are deployed, and you've generated this config.json file. So you want to go back to your Cloud Shell, and there's an upload-download icon up here at the top of the screen, or at the top of the PowerShell window, I should say. And you want to click download, and then just type in config.json. It's case sensitive, by the way, so capital C, and just download that file to your machine. Okay. Now you just drag that JSON config file onto the screen of the iOS simulator, and it's going to point the application to the new environment that you just set up. And then you're going to sign in. And this is using those credentials that were outputted by the PowerShell script. So we'll usually create kind of a long username. You can just copy the username from the PowerShell output and paste it in there, and then so right here, this is going to be your username, and then just use your password to sign in. Okay, and after you sign in, what's going to happen here is the iOS application is going to reach out to the FHIR server and check to see if there's been a patient created for this device. So essentially, you've logged in with this user, and it looks to see if there's a patient resource. It sees that it's a completely brand new environment, so it has you create a patient. Just create a test patient. You can fill out first, last name, birth date, and then just hit next. So this is going to actually create a patient resource in your FHIR server. And then here's where we're going to ask HealthKit for permission to access user data, user health data. So we're going to tap the Request Permissions button. And then you want to turn all categories on. So this is going to flip all of these switches to green, and then hit Allow. And so this will allow us to access all the data in the HealthKit on the iOS simulator. Okay. So after that's done, we just start observing. So when you click the Start Observing button, this actually sets up those observer queries using the HealthKit on FHIR framework. It's going to connect into HealthKit and say, I care about these types. So the types we're actually looking at right now are going to be heart rate, step count, blood pressure, and blood glucose. The heart rate and step count messages are actually sent up using the IoMT FHIR connector for Azure, and that's because they can be high frequency. Blood pressure and blood glucose in the sample app, they just write directly to FHIR. So we're going to exit the sample application, and you can do that by hitting Shift-Command-H, and then you want to launch the Apple Health app. Okay, and then you're going to tap on the Browse tab. And then Heart. Select that cell. And then heart rate. And we're just going to add a heart rate here. So you tap on Add Data. And then in this case, I'm just going to add a value and click the Add button. All right, now we can navigate back to the IoMT FHIR app. So again, Shift-Command-H. And we can select that heart rate message cell. Now, when we select this, it might take up to 5 seconds, because the first time you actually connect the IoMT FHIR connector to your FHIR server, it needs to do this, it needs to get authentication, so it needs to generate a token. So if it's not there, you just click back and then forward again, and it should be there. And the result of this is you're going to be able to view the observation JSON. And so if you're here for the previous session, you'll see that it created an observation with value sample data here, and the heart rate value is somewhere in the sea of E's. So again, if you're using a device that outputs measurements at a high frequency, these will be filled up more. And in fact, you can go back into the Apple Health app and add more heart rate data, and it'll start filling in this observation, or you can select a different hour, and you can create more observations for different hours. Okay, so in summary, we used the PowerShell script to deploy the IoMT FHIR connector for Azure, and also the Azure API for FHIR. Deployed that iOS sample application, and then added data to the Apple HealthKit on the simulator, and then verified that it actually went through the whole process of being read from HealthKit, transformed into a FHIR observation, and then stored in your FHIR server. Okay, guys, thank you very much. I put both repositories on here. So there's the IoMT FHIR repository. That's the IoMT FHIR connector for Azure, and then also the HealthKit on FHIR repository. So if you didn't get a chance to build during this session because you didn't have Xcode or you don't have a Mac, it's fine. Like I said, the slides are available. If you know somebody who would be interested in doing this, please pass on the information, and also we'll be at the Microsoft table in the back. And I think we have time for a few questions. No? Yes? So the question is, we're in discussions with device manufacturers, and he's wondering if I can talk about the device manufacturers we're working with. And it looks like my boss is shaking her head no. But I can tell you that's a device. It's an IoMT device. It generates data, and it flows through the IoMT connector for FHIR, and it actually works really well. Any other questions? Okay, thank you very much, guys.
Gone too soon. Wait, we was just hanging. I can't seem to hold on to. Dang, the people that know me best, the key that I won't forget.